When a program executes, it has two ways to remember things: the heap and the stack. The heap is usually where we store variables that we assign values to. And the stack is usually where we keep track of our function calls. Sometimes we want to optimize for using less memory instead of using less time. Talking about memory or space complexity is very similar to talking about the time cost. We simply look at the total size relative to the size of the input and see how many new variables or new memory we're allocating, how much memory is being used. So let's look at an example. Up to this point, we've talked about time complexity and how if we want to compress, let's say some boxes, we just talked about how fast and how many operations this would take. But in real life, there's this other factor of memory. And we have this pink little box of how much this function can take, how much input it's able to take. For example, if we had a ton of boxes that we have to create to run this function, well, it has limited capacity and it might overflow. By the way, things like Stack Overflow is something we're going to be talking about and how it's an issue when it comes to memory. Something we'll cover when we get into recursion. What causes this space complexity? Well, luckily for you, I added this to our cheat sheet. What causes space complexity? Well, adding variables, adding data structures like arrays, objects, hash tables, again, things we'll talk about, function calls, and allocations. We don't need this period. But let's actually code something and show you an example. In the next video, we'll go through some space complexity exercises and figure out how we can give big O notation to the subject.